The morning of November 24th, 1944, Captain Hanji Matsumura stood on the observation deck of the Nakajima Aircraft Company's main factory in Musashino, just outside Tokyo. Through the haze of machine oil and metal dust, he watched workers hand-fitting aluminum panels to a single-engine fighter frame. The process was meticulous, almost artisanal. Each rivet is placed with care, each panel measured twice, fitted once. The fighter would be excellent when complete, a testament to Japanese craftsmanship and engineering precision. 300 miles to the south, across the Pacific, something else was happening. At Boeing's facility in Wichita, Kansas, a B-29 Superfortress rolled off the production line. Then another, 4.2 complete aircraft every single day, each one weighing 35 tons empty, each one capable of carrying 10 tons of bombs across 2,000 miles of ocean. Matsumura did not yet know these numbers. None of them did. But within months, the mathematical reality of American industrial capacity would become impossible to ignore, written in fire across Japanese cities, encoded in the unending stream of silver bombers that filled the sky. This is the story of how Japan's military and industrial leadership came to understand too late that they were not fighting an enemy army. They were fighting an enemy factory system so vast, so efficient, so overwhelming that victory had been mathematically impossible from the moment the first shot was fired at Pearl Harbor. The question that haunted Japanese engineers and officers in the final year of the war was simple and terrible. How do you defeat a nation that can build more in a single day than you can build in a month? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. In January of 1940, when the United States Army Air Corps issued its request for a new heavy bomber design, Japan was already deep into its war with China. The Marco Polo Bridge incident of 1937 had escalated into a full-scale conflict that consumed enormous resources. Japanese industry, which had grown impressively since the Meiji Restoration, was stretched thin, supplying an army of over 1 million men fighting across the vast expanses of China. Steel production had risen from 6.4 million tons in the early 30s to 8.8 million tons by 1941. Aircraft production capacity stood at 10,000 planes per year. These were respectable numbers for a nation with limited natural resources. Japanese military planners knew they could not match American industrial output ton for ton. This was not a secret. Imperial Navy studies, conducted in 1941, clearly showed the disparity in production capacity between the two nations. Admiral Isoroku Yamamoto, who had studied at Harvard and served as a naval attaché in Washington, understood American industrial might better than most. He had toured automobile factories in Detroit, watched cargo ships being loaded at eastern ports, seen the vast rail networks that connected American industry. When asked about a war with the United States, he famously predicted he could run wild for 6 months to a year, but after that, he had no confidence in Japan's prospects. Yet the war came anyway. The strategic calculation was not based on ignorance but on desperation and hope. Japan imported 80% of its oil from the United States and British territories. When the American oil embargo was imposed in August 1941, Japan's military had fuel stocks for approximately 6 months of operations. The choice, as articulated by Prime Minister Hideki Tojo, was between submission or war. They chose war, gambling that early victories would create a defensive perimeter so costly to breach that America would negotiate rather than fight a prolonged conflict. It was a gamble based on a profound misunderstanding of American psychology and industrial capability. The plan seemed sound in theory: strike hard at Pearl Harbor, cripple the Pacific Fleet, seize oil fields in the Dutch East Indies, capture defensive positions across the Pacific, and present America with a fait accompli. The Americans, still emerging from the Great Depression, still divided over intervention, would lack the will to mount a years-long campaign to retake scattered island possessions. Or so the thinking went. Japanese war planning assumed that spirit, tactical excellence, and initial surprise would offset material disadvantage. The warrior culture that had defined Japanese military tradition for centuries emphasized willpower over weaponry, the intangible force of human determination over cold industrial calculation. This belief system was not entirely without merit. Japanese forces in the opening months of the war demonstrated remarkable tactical proficiency. The fall of Singapore in February 1942 resulted in the surrender of 80,000 British, Australian, and Indian troops, the largest capitulation of British-led forces in history. Japanese naval aviators, among the best trained in the world, achieved stunning victories at Pearl Harbor and in the early carrier battles. Japanese soldiers, indoctrinated with the code of Bushido, fought with a ferocity that shocked their opponents. For a brief moment, the gamble appeared to be paying off, but the gamble was already lost, decided by factors most Japanese planners had failed to adequately consider. The United States in 1941 possessed something Japan did not: massive excess capacity. The Great Depression had left 10 million Americans unemployed. Factories ran at low utilization rates. When war mobilization began, this dormant capacity roared to life. Workers who had been idle found jobs in defense plants. Assembly lines that had been silent began running multiple shifts. The American economy, which Japanese planners had viewed as soft and unprepared, transformed with stunning speed into the most formidable war production machine in human history. The Boeing B-29 Superfortress project exemplified everything Japan failed to grasp about American industrial capability. The request for proposals went out in January 1940. Boeing submitted its Model 345 design in May. By September of that year, Boeing received orders for 2 experimental prototypes. In December, the Army Air Corps ordered 14 additional test aircraft. Then, in an act that would have been unthinkable in Japanese military procurement, the Air Corps ordered an additional 500 production aircraft in May 1941, 16 months before the first prototype would even fly, 7 months before Pearl Harbor. This was not recklessness. It was industrial confidence. American military planners understood that Boeing's engineering teams could solve technical problems during production, that the vast network of subcontractors could be mobilized, that sufficient aluminum, steel, copper, and skilled labor could be found. They understood that even if the B-29 encountered problems, which it did, American industry had the capacity to fix them while maintaining production. This mindset was alien to Japanese military thinking, where resources were scarce and every decision involved painful trade-offs. The first XB-29 prototype took its maiden flight on September 21, 1942. The aircraft was a technological marvel. At 99 feet long with a wingspan of 141 feet, it was among the largest aircraft in the world. It featured a pressurized cabin, the first purely military aircraft designed with this capability, allowing crews to operate comfortably at altitudes exceeding 30,000 feet. 4 Wright R3000, 350 duplex Cyclone engines, each generating 2,200 horsepower, gave the aircraft a top speed of 357 miles per hour and a range of 3,250 miles. The defensive armament included 4 remote-controlled turrets housing twin 50-caliber machine guns, plus a manned tail turret with 2 more 50-caliber guns and a 20mm cannon. The B-29 carried 11 crew members and could deliver up to 20,000 pounds of bombs. Its service ceiling of 31,850 feet placed it beyond the effective reach of most Japanese fighters and anti-aircraft guns. The aircraft incorporated innovations that represented the cutting edge of aviation technology: analog computers for fire control, high aspect ratio wings for efficient high-altitude flight, tricycle landing gear, and sophisticated avionics systems. But the truly remarkable aspect of the B-29 was not its design. It was that America could build it in quantity. Each aircraft required 12 tons of aluminum sheeting, over 1,000 pounds of copper, 600,000 rivets, approximately 9.5 miles of wiring, and 2 miles of tubing. The construction process demanded 33,000 man-hours of labor. By any measure, the B-29 was an enormously complex machine, incorporating 40,000 different parts. Yet American industry prepared to manufacture it on an unprecedented scale. 4 major assembly facilities were designated for B-29 production. Boeing operated plants in Wichita, Kansas, and Renton, Washington. Bell Aircraft established a facility in Marietta, Georgia. The Glenn Martin Company built a plant in Omaha, Nebraska. Each facility employed tens of thousands of workers. The Wichita plant alone, completed in 1942, covered 185 acres with 2.8 million square feet of space. The main assembly floor measured 1.7 million square feet, with 2 primary assembly lines stretching 750 feet in length, under a 300-foot wide roof. Boeing engineer Oliver West developed an innovative multi-lining system to handle the B-29's complexity. Traditional aircraft assembly used a single line where the aircraft moved from station to station. West replaced this with 6 parallel lines feeding into 3 final assembly positions. Workers on each line handled specific sections of the aircraft: forward fuselage, wings, tail section, engine nacelles. These sections remained stationary until completion, then were transported by crane to the final assembly bay, where 4 complete B-29 seconds could be assembled simultaneously. This approach allowed workers to develop specialized expertise, reduced the movement of heavy components, and enabled multiple aircraft to progress through different construction phases concurrently. The system worked, but not without enormous difficulties. The B-29 program experienced what became known as the Battle of Kansas, a massive troubleshooting effort to overcome the technical problems that plagued early production. The Wright R-3350 engines were powerful but temperamental. They overheated frequently due to inadequate cowling design and the engine's high power-to-weight ratio. On February 18, 1943, the second XB-29 prototype crashed during testing when an engine fire spread to the wing, killing all 10 crew members and 20 workers in a meatpacking plant below. Changes to the aircraft came so rapidly that B-29 seconds, leaving the production lines in early 1944, flew directly to modification depots for extensive rebuilds to incorporate the latest fixes. It was chaos, but it was controlled chaos, backed by unlimited resources and determined leadership. General Henry Hap Arnold, commanding general of the Army Air Forces, personally intervened to keep the program on track. His deputy later recalled that Arnold's life was consumed by the B-29, that he was involved in every detail of the aircraft's development and production. The investment was staggering. The B-29 program ultimately cost $3 billion, equivalent to approximately $52 billion in current currency. This exceeded the $1.9 billion spent on the Manhattan Project. Each production B-29 cost $639,000, more than double the cost of a B-17 Flying Fortress. Yet orders kept coming. By war's end, America would build 3,970 B-29 seconds. The production rate achieved by mid-1944 would have seemed impossible to Japanese observers. At Boeing's Wichita plant, which had initially required 157,000 man-hours to build each of the first 100 aircraft, the workforce eventually reduced this to less than 20,000 man-hours per aircraft. The plant operated continuously, with workers on multiple shifts, keeping the assembly lines running around the clock. By the war's end, Boeing Wichita was producing 4.2 complete Superfortresses per working day, an average of 100 aircraft per month. 4 aircraft every day, just from Wichita. The other 3 plants added their own production. The scale of this achievement is difficult to overstate. In the time it took Japanese factories to hand-build a single bomber, using artisanal techniques and scarce materials, American factories produced dozens of B-29 seconds, each one technically superior to anything in the Japanese arsenal. Japanese intelligence did attempt to track American production. Their estimates of U.S. warship construction were reasonably accurate, close enough for strategic planning, but they stumbled catastrophically on merchant shipping, estimating American construction capacity in 1943 at 5 million tons, when the actual figure was 19.2 million tons, nearly 4 times their estimate. This was not a small error. It represented a fundamental failure to comprehend the scale of American industrial mobilization. The problem extended beyond mere numbers. Japanese intelligence officers could collect data on American factories, production targets, and resource allocation. What they could not grasp was the quality of American industrial management, the efficiency of American logistics, the sophistication of American training systems, and the innovative approaches to mass production that American engineers pioneered. Japan could understand American quantity, but failed to conceive of American quality mated to incredible quantity, combined with sound strategic thinking, managerial expertise, and globe-spanning logistics. This failure stemmed partly from cultural assumptions. Japanese aviation training, for example, was notoriously difficult. Naval aviator training produced superb pilots but did so inefficiently, selecting only the most naturally gifted candidates and subjecting them to years of rigorous preparation. Japanese planners assumed American training systems operated similarly. If Japan could not rapidly produce competent pilots from average recruits, then America couldn't either. This assumption was wrong. American training programs, backed by modern educational infrastructure and systematic instructional methods, transformed civilians into capable pilots, mechanics, and specialists in months rather than years. The same blindness affected assessments of industrial capacity. Japanese factories operated under constraints that had become almost invisible through familiarity. Scarce raw materials meant careful allocation. Limited skilled labor meant artisanal production methods. Modest factory sizes meant sequential rather than parallel production. These constraints shaped Japanese assumptions about what was possible. When intelligence reports indicated American production levels that exceeded Japanese capabilities by factors of 5, 10, or 20, these numbers seemed implausible. Surely the Americans were exaggerating for propaganda purposes. Surely their equipment was shoddy, mass-produced junk that would fail in combat. Surely their soldiers, soft from years of Depression-era unemployment, lacked the fighting spirit of Japanese warriors. Each assumption was wrong, and nowhere did the terrible reality become more evident than in the skies above Japan when the B-29 seconds arrived in force. The first B-29 raid on Japan launched on June 15, 1944, from bases around Chengdu in China's Sichuan province. 68 aircraft took off, 47 reached the target at Yawata. The results were modest. Japanese air defenses engaged the bombers with some success. Anti-aircraft fire damaged several aircraft. Fighters managed to shoot down some of the raiders. The Japanese government reported minimal damage. In Tokyo, military leadership breathed easier. The American super bomber had proven vulnerable after all. This optimism would not last. The logistical challenges of operating B-29 seconds from China were immense. Every gallon of fuel, every bomb, every spare part had to be flown over the Himalayas from India, a route pilots called the hump. For every gallon of fuel a B-29 used on a combat mission, 6 gallons had to be transported over the mountains just to stockpile sufficient reserves. The tonnage consumed by B-29 operations represented 15% of all cargo flown over the hump, creating tensions with other Allied operations in China. The entire arrangement was inefficient, a temporary measure until better bases could be secured. Those bases came in the summer of 1944, when American forces captured the Mariana Islands Saipan, Tinian, and Guam. These islands sat 1,400 miles from Tokyo, well within the B-29's operational range. More importantly, they could be supplied by sea, eliminating the logistical nightmare of the hump. Construction battalions immediately began building massive airfields. The scale of construction was itself a demonstration of American capability. On Tinian alone, engineers built Northfield, which eventually featured 4 parallel runways, each 8,000 feet long. At peak operations, Northfield would become the busiest airfield in the world, launching B-29 seconds at intervals measured in seconds. The first B-29 arrived on Saipan on October 12, 1944. The first combat mission from the Marianas launched on October 28 against the Truk Atoll. Then came the mission that changed everything. November 24, 1944. 111 B-29 seconds took off from bases in the Marianas, destination Tokyo. This was no probing raid. This was the beginning of a sustained strategic bombing campaign that would continue until Japan's surrender. Japanese radar stations detected the incoming formation while it was still over the ocean. Air raid sirens wailed across Tokyo. Civilians who had experienced the Doolittle raid in April 1942 and a handful of subsequent minor attacks assumed this would be similar, a few bombers causing limited damage, more of a propaganda gesture than a serious military threat. Some residents dutifully filed into shelters. Many did not bother. The formation that appeared over Tokyo that day was unlike anything Japanese civilians or military personnel had experienced. Wave after wave of massive silver aircraft, flying in formation at altitudes that made them appear as tiny glints of reflected sunlight. Japanese fighters scrambled to intercept. Army Type 4 Hayate fighters and Navy J-2M Raiden interceptors climbed desperately, their engines straining. A few managed to reach the B-29 seconds altitude. Fewer still could match the bomber's speed while maintaining combat effectiveness at such heights. The bomber's defensive armament proved formidable. The remote-controlled turrets, directed by central fire control computers, created overlapping fields of fire that made attacking runs extremely hazardous. Some bombers were damaged, some were shot down. But the raid achieved its objective. It demonstrated that American B-29 seconds could strike Tokyo at will, that Japanese air defenses could not stop them, and that this was only the beginning. Over the following weeks, the raids continued. Small formations at first, testing Japanese defenses, gathering intelligence, training crews in the long overwater navigation required for these missions. Then came the tactical shift that would define the campaign's final months. Major General Curtis LeMay assumed command of XXI Bomber Command in January 1945. LeMay had built a reputation in Europe as a ruthless, innovative tactician willing to challenge conventional doctrine. He looked at the B-29 operations and saw waste. The aircraft had been designed for high-altitude precision bombing, the same doctrine the 8th Air Force employed over Germany. But weather conditions over Japan, particularly the jet stream winds at high altitude, made precision bombing nearly impossible. Bombs dropped from 30,000 feet scattered unpredictably. Hit rates were abysmal. Resources were being expended with minimal results. LeMay studied the target, Japanese cities. Unlike European cities with their stone and brick construction, Japanese urban areas consisted largely of wooden buildings. Japanese industry had not concentrated in massive factories as in America or Germany. Instead, cottage industries operated throughout residential neighborhoods. Small workshops produced components that were assembled in larger facilities. Destroying Japanese industrial capacity meant destroying these dispersed cottage industries, which meant destroying the residential areas where they operated. LeMay made a decision that remains controversial. Strip the B-29 seconds of most defensive armament to increase bomb load. Conduct raids at night to reduce visibility for fighters and anti-aircraft gunners. Fly at low altitude 5,000 to 7,000 feet, where the bombers would be more accurate and could carry more ordnance. And use incendiary bombs rather than high explosives. Burn the cities. The test of this new tactic came on the night of March 9th to 10th, 1945. The target was Tokyo. The mission, code-named Operation Meeting House, would become the single most destructive air raid in human history. Just after 5:30 in the evening on March 9th, the first B-29 lifted off from Guam's North Field. Another followed at 50-second intervals, then another. From Guam, Saipan, and Tinian, the silver giants climbed into the darkening sky. 279 bombers in total, each loaded with incendiary clusters, M69 bombs designed to scatter burning gel across wide areas. The bombers carried no ammunition for most of their guns. Every available pound of weight capacity had been allocated to bombs. The aircraft flew individually rather than in formation, following predetermined routes that would converge on Tokyo from multiple directions. Pathfinder aircraft went in first, dropping their loads to mark the target. Their incendiaries burst into flames, creating an enormous fiery X visible for miles. Then the main force arrived. Bomber after bomber released its payload over the designated area, a rectangle approximately 3 miles by 4 miles in eastern Tokyo, specifically chosen because intelligence indicated a high concentration of cottage industry workshops mixed among densely packed wooden residences. The incendiaries fell like rain. Each M69 cluster separated at altitude, scattering individual bomblets across a wide area. When the bomblets struck the ground, they ignited, spraying burning gel that stuck to whatever it touched. Within minutes, thousands of individual fires merged into hundreds of larger blazes. Within an hour, those blazes had combined into a firestorm. A firestorm is not simply a large fire. It is a meteorological phenomenon where intense heat creates powerful updrafts that draw in air from surrounding areas, creating hurricane-force winds that feed the flames. The firestorm over Tokyo generated winds exceeding 60 miles per hour. Surface temperatures reached 1800 degrees Fahrenheit. The updrafts were so powerful they created turbulence that affected the B-29 seconds flying overhead. Crews reported sudden altitude changes of 1,000 feet. Some aircraft were flipped inverted by the violent air currents. Pilots found themselves flying upside down, everything inside the aircraft crashing against the ceiling, the flames that had been below them now above them. Those in the bombers could see the devastation they were creating. Richard Bailey of the 9th Bombardment Group, flying in the rear of the formation, later recalled that he could almost read a paper in the cockpit due to the intensity of the fires below. The glow was visible from 150 miles away. The smell of burning wood, burning fuel, and burning flesh penetrated even the sealed cabins of the B-29 seconds flying at altitude. On the ground, conditions were indescribable. The firestorm created a hellscape beyond rational comprehension. Wooden buildings exploded into flames, roads melted, canals boiled. People fleeing the flames found themselves trapped as fires spread faster than they could run. Those who sought shelter in supposedly fireproof buildings discovered that while the structures might not burn, the heat inside rose to lethal levels. Refugees who jumped into water to escape the flames were boiled alive. Others suffocated as the firestorm consumed the oxygen in the air. Bodies were found the next day carbonized in positions of flight, people who had been running when the heat flash incinerated them. The raid lasted approximately 3 hours. By dawn on March 10th, the fires had consumed 16 square miles of Tokyo. More than 250,000 buildings had been destroyed. Over 1 million people were homeless. The death toll remains uncertain estimates, range from 80,000 to over 110,000 killed in a single night. This exceeded the immediate death toll from either atomic bomb that would be dropped 5 months later. It was the deadliest air raid of the war, any war, before or since. American losses were comparatively minimal. 14 B-29 seconds failed to return, lost to mechanical failures, accidents, or the handful of Japanese fighters and anti-aircraft batteries that managed to engage the raiders effectively. 90 airmen were missing. Against the apocalyptic destruction inflicted on Tokyo, these losses seemed acceptable to American commanders. For the first time, large numbers of Japanese civilians understood that the war was lost. No amount of government propaganda could explain away what had happened. The evidence was written in ash and rubble across 16 square miles of their capital city. More raids followed. Nagoya on March 11th and 12th, Osaka on March 13th and 14th, Kobe on March 16th and 17th. Every major Japanese city was systematically targeted. By the summer of 1945, Japan's urban areas had been reduced to ruins. The psychological impact extended beyond the civilian population. Japanese military and government officials, who had maintained optimistic assessments of the war situation, could no longer deny reality. The B-29 raids demonstrated several devastating truths simultaneously. First, American industrial capacity was producing bombers in quantities that dwarfed anything Japan could build or destroy. For every B-29 shot down, 3 more appeared. The stream was endless. Second, Japanese air defenses were inadequate. Fighters could not intercept effectively at high altitude and struggled to find targets during low-altitude night raids. Anti-aircraft guns lacked the sophisticated fire control systems and proximity-fused shells that made American anti-aircraft defenses so effective. Third, and perhaps most importantly, the raids proved that America possessed both the will and the capacity to wage total war against Japan's home islands. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The cottage industry system that had seemed like a strength, distributing production across thousands of small workshops to make targeting difficult, became a fatal vulnerability. Destroying these dispersed facilities required destroying the cities that housed them, and America had both the bombers and the ordnance to accomplish this task. Japanese production figures reflected the impact. Aircraft production, which had peaked in July 1944 at 2,541 airframes per month, collapsed. By war's end, Japanese factories could barely maintain a fraction of that output. The problem was not just physical destruction of facilities. Workers were dead, homeless, or spending their time securing food and shelter rather than manufacturing aircraft. Supply chains were disrupted, transportation networks were in ruins, raw materials could not reach factories, and finished goods could not be distributed. The naval blockade compounded these problems. American submarines and aircraft had severed the shipping routes that brought raw materials from conquered territories to Japan's home islands. Japan's industrial economy depended utterly on imports: oil from the Dutch East Indies, rubber from Malaya, coal and iron from Manchuria, and rice from Southeast Asia. As American forces captured islands across the Pacific and submarines decimated merchant shipping, these resources stopped flowing. By 1945, Japan was starving both literally in terms of food and figuratively in terms of industrial inputs. Steel production, which had reached 8.8 million tons in 1941, plummeted. Aluminum production, essential for aircraft manufacturing, became sporadic as bauxite imports ceased. Coal production declined as miners were drafted into the military or killed in air raids. The electrical grid, never robust, suffered from lack of maintenance and fuel shortages. Factories that had escaped bombing sat idle for want of power, raw materials, or workers. In this context, the production figures from American factories took on almost mythical dimensions. Japanese engineers and officers who had access to intelligence reports saw numbers that seemed impossible. They read that American factories produced more aircraft in 1944 alone than Japan had manufactured during the entire war. They learned that U.S. steel produced more steel in a month than Japan's entire annual capacity. They discovered that American shipyards were launching merchant vessels and warships at rates that made Japan's naval construction program seem like a craft workshop. The specific B-29 production numbers would have been particularly devastating to comprehend. 4.2 aircraft per day from Wichita alone. Add Renton, Marietta, and Omaha, and the combined output exceeded 15 B-29 seconds daily at peak production. 15 of the world's most advanced heavy bombers, each one representing technology Japan could not match, and manufacturing capacity Japan could not approach. Every single day, 7 days a week, month after month. Even these numbers understated American capability because they counted only B-29 seconds. The same industrial system was simultaneously producing thousands of P-51 fighters, B-24 and B-17 bombers, C-47 transport aircraft, thousands of tanks, tens of thousands of trucks, millions of artillery shells, billions of rounds of ammunition, and a naval fleet that by 1945 dwarfed every other navy in the world combined. Some Japanese officials had understood this disparity from the beginning. Admiral Yamamoto's warnings about American industrial potential had proven prophetic. Finance Minister Takahashi Korekiyo, before his assassination by military extremists in 1936, had pointed out that Japan's own military depended on American raw materials and technology. By going to war with the United States, Japan would not only face a stronger opponent but would cut itself off from the economic resources it needed to fight. His warnings went unheeded. Even those who understood the numbers had failed to grasp their implications. Japan's leadership assumed that spirit, tactical excellence, and willingness to accept casualties would offset material disadvantage. The warrior ethos that had served Japan well in the Russo-Japanese War of 1905, when superior morale and tactics had defeated a larger Russian force, seemed applicable to the conflict with America. But the industrial warfare of 1945 bore no resemblance to the warfare of 1905. By the 20th century's midpoint, wars between major powers had become industrial competitions. Victory went not to the side with braver soldiers or better tactics, but to the side that could produce more tanks, more planes, more ships, more bullets than the enemy could destroy. Japan had entered this competition with a fundamental handicap. The Japanese economy before the war represented approximately 5% of global industrial capacity. They were attempting to fight a nation that possessed roughly 10 times their manufacturing output. Moreover, America's geographic position meant its factories were invulnerable to attack. Japan could not bomb Detroit or Pittsburgh or Wichita. The industrial heartland that produced the weapons destroying Japan was utterly safe from retaliation. Meanwhile, every major Japanese city sat within range of B-29 seconds, operating from the Marianas. The asymmetry was total and unbridgeable. No amount of courage could overcome it. No tactical brilliance could compensate for it. No wonder weapons could reverse it. Japan's situation by mid-1945 was hopeless by any rational assessment. Yet the war continued because the military leadership could not admit defeat, because the cultural concept of surrender was intolerable, because the entire ideological structure of wartime Japan had been built on the premise that spiritual strength would overcome material weakness. That premise lay in ruins across the burned cities of Japan. Every B-29 raid reinforced the same message. You cannot win an industrial war against an opponent who produces more in a day than you produce in a month. The mathematical inevitability of defeat had been written into the war's fundamental parameters from December 7, 1941. Everything that followed was merely the working out of that equation. A slow-motion collapse as industrial disparity ground Japanese resistance into dust. The atomic bombs dropped on Hiroshima and Nagasaki in August 1945 are often credited with forcing Japan's surrender. There is truth to this. The atomic weapon demonstrated a new order of destructive capability that made continued resistance seem even more futile. But Japan had already been defeated by conventional means. The B-29 campaign had destroyed Japan's industrial capacity, killed hundreds of thousands of civilians, and made normal economic life impossible. The naval blockade had cut off food and raw materials. The Soviet entry into the war eliminated any hope of a negotiated peace through Moscow's mediation. In the weeks following Japan's surrender, American occupation personnel interviewed thousands of Japanese civilians. Approximately 70% reported that by early August 1945, they had reached the point where they felt unable to endure one more day of war. The psychological breaking point had been reached before the atomic bombs fell. The firebombing campaign had accomplished what strategic bombing theorists had long predicted. It had broken the enemy's will to resist by making the cost of continued resistance unbearable. Japanese engineers and industrialists, no longer constrained by military censorship, could finally discuss openly what many had known privately for months or years. American productive capacity had been orders of magnitude greater than Japanese capability. The quality of American machine tools, the sophistication of American production techniques, the efficiency of American industrial management, all of these had been superior. Japan's aircraft, while well designed by individual engineers working with available resources, had been produced by methods that belonged to an earlier era. Hand-fitting of parts, individual attention to each assembly, artisanal approaches that produced excellent individual units but could not scale to meet wartime demands. American aircraft rolled off assembly lines where workers performed specialized tasks in sequence, where interchangeable parts meant minimal hand-fitting, where the entire process had been studied and optimized for maximum throughput. Boeing's multi-lining system for the B-29, which had seemed so innovative, was simply an application of principles that Henry Ford had developed decades earlier for automobile production. Japanese industry knew these principles in theory, but had never implemented them at scale because the necessary prerequisites, abundant raw materials, large pools of skilled labor, substantial capital investment, and most crucially, vast markets to absorb mass-produced goods had been lacking. The American economy before the war had been the world's largest, a continental market of over 130 million consumers with the highest per capita income in the world. This enormous domestic market had driven the development of mass production techniques. Companies that could reduce costs through efficient production could expand market share and profits. Competition drove innovation in manufacturing methods. When war came, these same techniques applied to military production created the arsenal of democracy. Japan's economy, constrained by limited domestic resources and smaller markets, had developed differently. Japanese firms focused on quality production for elite markets rather than mass production for wide distribution. This approach worked well for luxury goods, precision instruments, and specialized products. It was catastrophically inadequate for industrial warfare, where victory required producing acceptable quality equipment in overwhelming quantities rather than producing perfect equipment in limited numbers. The irony is that Japan would eventually master mass production techniques. In the post-war period, as American occupation authorities worked to rebuild Japanese industry, Japanese engineers studied American manufacturing methods with the intensity of desperate students. The occupation's civil communications section, staffed by engineers from AT&T, MIT, and other American institutions, introduced Japanese managers to quality control, methods, scientific management principles, and production efficiency techniques. These lessons were absorbed, adapted, and eventually refined. By the 1980s, Japan had become synonymous with manufacturing excellence. Japanese automobiles, electronics, and machinery were renowned for quality and efficiency. The techniques that had defeated Japan in 1945 mass production, interchangeable parts, statistical quality control had been mastered and improved upon. Toyota's production system became the global standard for automotive manufacturing. Japanese consumer electronics dominated world markets. The student had surpassed the teacher in many respects. But in 1945, as Emperor Hirohito's radio broadcast announced Japan's acceptance of the Potsdam Declaration's terms, the lesson was fresh and bitter. Modern industrial warfare could not be won by courage alone. The warrior spirit that Japanese culture had cultivated for centuries was no match for the assembly line, the efficient factory, the well-managed supply chain, material factors that Japanese military culture had dismissed as secondary considerations, logistics, production rates, resource allocation had proven decisive. The war had been a collision between two fundamentally different systems, one based on traditional warrior values adapted to industrial-age technology, the other based on ruthless industrial efficiency harnessed to military purposes. The specific numbers drove the point home with brutal clarity. Japan's steel production is 1941, 8.8 million tons annually. American steel production in 1944, 80 million tons. Japanese aircraft production for the entire war, approximately 76,000 aircraft. American aircraft production from 1941 through 1945, 300,000 aircraft. Japanese merchant ship construction during the war, 4.1 million tons. American merchant ship construction during the war, 53 million tons. These were not small differences. They were categorical disparities that made defeat inevitable regardless of tactical decisions or individual heroism. For every Japanese pilot who died crashing his aircraft into an American warship, America produced 10 new pilots and 5 new ships. For every Japanese factory worker who died at their post during a bombing raid, America trained 20 new workers in safer factories that Japanese forces could never reach. The mathematics of industrial warfare were inexorable. Captain Matsumura, the officer who had watched workers carefully assembling a fighter in November 1944, survived the war. After Japan's surrender, he worked briefly with American occupation authorities, helping to assess damage to Japanese industrial facilities. In that capacity, he had access to intelligence reports he had never seen during the war, reports on American production capacity, factory efficiency studies, analyses of the industrial disparity between the two nations. He later wrote in his private journal, discovered decades after his death, about the moment he fully understood what Japan had faced. Reading a report on Boeing's Wichita facility, seeing the production numbers, and understanding that a single American factory produced more heavy bombers in a month than all of Japan's aircraft industry produced in that same period, he felt not anger, but a kind of dazed comprehension. The war had never been winnable. The moment the first bomb fell on Pearl Harbor, Japan's defeat had been mathematically guaranteed. Everything that followed the battles, the casualties, the destruction of Japanese cities, the deaths of millions had been inevitable consequences of attempting to fight an industrial war against an opponent with 10 times the productive capacity. His final entry on the subject was simple. We fought the wrong war against the wrong enemy. We brought samurai swords to a battle of factories. They buried us in steel. The B-29 production rate, 4.2 aircraft per day from a single factory, was not just a statistic. It was a symbol of everything Japan had failed to understand about modern warfare. Those silver bombers that filled the skies over Japan in 1945 were not merely weapons. They were manifestations of an industrial system so vast, so efficient, so utterly dominant that resistance was futile. Each bomber represented not just the aluminum, copper and steel of its construction, not just the 33,000 man-hours of labor required to build it, but the entire productive apparatus of American industry, the mines that produced the raw materials, the mills that refined them, the factories that shaped them, the transportation networks that moved them, the training systems that produced skilled workers, the educational institutions that created engineers, the financial systems that allocated capital, and the political economy that coordinated all of these elements toward a common purpose. Japan had no equivalent system. could not build one, could not compensate for lacking one through superior tactics or greater sacrifice. The industrial age had rendered the warrior spirit obsolete as a decisive factor in great power conflict. Wars were now won by factories, by supply chains, by production rates, by logistical efficiency. The nation that could produce more while maintaining quality would defeat the nation that produced less, no matter how valiantly the latter's soldiers fought. This truth, so clearly written in the ashes of Japanese cities, would shape military thinking for generations. The Cold War competition between the United States and Soviet Union became fundamentally a contest of industrial capacity and technological innovation. Nuclear weapons added a new dimension of terror, but the underlying logic remained: material superiority, particularly in production capacity, provided decisive advantage. Wars were still won by the side with more tanks, more planes, more missiles, more of everything. Japan's experience in World War II served as a permanent reminder of what happened when nations miscalculated industrial disparities. Modern military analysts, studying potential conflicts between great powers, still begin with industrial capacity assessments. Can the nation sustain wartime production rates? Does it have secure access to critical raw materials? Can its factories survive enemy attack? Can it train workers faster than they are killed? These questions, which Japanese planners in 1941 answered with hope and prayer rather than cold analysis, remain central to strategic planning. The assembly lines at Boeing's Wichita plant fell silent after the war. The massive facility that had produced 4,200 B-29 seconds at peak efficiency transitioned to other projects, later Boeing bombers, eventually commercial aircraft components. The workers who had achieved such remarkable production rates returned to civilian life, their contribution to victory largely unrecognized outside official statistics. But their work had helped decide the war's outcome as surely as any soldier's sacrifice on a battlefield. 4.2 bombers per day. The number seems modest now, in an era where aerospace companies discuss production rates in hundreds of units per year. But in 1944 and 1945, that number represented the difference between victory and defeat. Each bomber that rolled off the line was another nail in Japan's coffin, another mathematical proof that the war was lost, another herald of inevitable surrender. Japanese engineers who eventually learned these numbers understood that their nation had never stood a chance. The war had been decided by factors beyond courage, beyond tactics, beyond everything except industrial capacity. And in that contest, America's advantage had been so overwhelming that the outcome was never in doubt. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.